Hi everyone, my name is Lina Aksu. I'm a recent graduate of TED University, Civil Engineering Department. This article was written with equal contributions of my colleagues Tuğba Sevgi Dursun, Buse Aleyna Ülkü, and Diyar Önal under the consultation of Associate Professor Baran Aktaş. Today I will be going to talk about augmented reality and drone usage in construction industry. There is a common sense that the construction sector is a more traditional sector in terms of technological developments. However, this situation has changed in recent years. The technologies that are expected to have an impact on the sector includes increased simulation capabilities and possesses mobile interfaces, such as augmented reality, 3D scanning, and unmanned aerial vehicles or drones, among others. The aim of our paper is to exhibit possible usages of technologies within the construction sector to increase productivity by using augmented reality and drones. So this presentation includes augmented reality, potential benefits of augmented reality, levels of AR implementation, defect management, drones at construction sites, and we will continue with an exemplar software and its capabilities with a case study and conclusion and a Q&A session. So augmented reality is the technology that expands our physical world, adding layers of digital information onto it. Its application to construction projects creates a system that provides a detailed digital model. This detailed model is able to demonstrate how a project will appear at the end with all details embedded inside the model. It can be used for any phase of the construction project. The model can be situated or added on top of existing construction sites to combine reality with digital models effectively. So what are the benefits? There are actually several benefits of using augmented reality in construction project administrations and management, including scheduling and project progress tracking, better collaboration and communication, time and cost management, safety and employee training. AR facilitates scheduling and project progress tracking through enhanced digitalization, so it enables better control of the project and improves visualization. The technology gives a chance to combine and compare constructed project and planned project at the construction site. It makes it easier to schedule an efficient construction and the logistics plan for the site. Moreover, the amount of material that is needed at the site and equipment storage can also be identified with this technology. So it enables better collaboration and communication among project parties. The system provides quick access through mobile phones. As it can be seen in this picture, AR includes different units of projects. It eases the communication with external stakeholders or with the customer while presenting project progress and visualizing the final product. In summary, better suggestions, comments, and decisions can be made by using augmented reality technology in construction works. Time and cost management. AR partially resolves errors related to misinterpretation from 2D drawings. Also, the usage of AR reduces the number of manpower needed for the defect and quality management, which means less labor, therefore reduced cost of construction. Construction sites includes many heavy equipment that should be safely operated. Training laborers and field personnel for operating the machines takes long hours. However, workers can be trained by using AR. For example, workers can be trained to operate heavy and medium construction cranes, maybe excavators and assembling equipments too. So there are different levels of AR implementation. Augmented reality is not a standard package that can be installed, bought, or used readily. There are different defined levels based on degree of sophistication and technology involvement. It goes from level 1, which is the most fundamental level, to level 5, which is advanced. Companies planning to implement AR should select an appropriate level system based on their needs, expertise, and technical and financial capabilities to avoid detraction from under or maybe over adoption of the system. In Turkey, the companies are overall lagging behind compared to companies grow into more developed economies. However, there are some large construction companies in Turkey who are experimenting with level 3 systems. It is expected that the number of companies exploring this technology will increase in the future. So moving forward, we have defect management. Defect management has a great influence on project overrun costs, time, materials, and manpower also. So it can be said that defect management during the construction phase is important to prevent further problems that can occur during the life cycle of the structure. So there are studies concerning defect management systems. However, they are not usually concerned with the information flow from defect detection. So the outcome is reactive defect management plans. The mixed usage of technologies such as AR, drones, and building information modeling, a new proactive approach to defect management can be created by enhancing and tying together the visualization, communication, and information flow. It is often challenging to make quality inspections at a large construction site with limited number of site managers, and it is risky in terms of omissions and faulty decisions, which leads to negative effects on project cost and schedule. Here you can see a scheme, a traditional defect inspection process, which is actually quite a long path to follow. So, however, two methods for defect management have been proposed in academic literature to create a proactive approach. One utilizes AR at the construction site with an image matching system that enables users to make quality inspections without visiting the work site. And the other one is a mobile computing-based image matching system together with AR defect application. So drones at construction sites. In areas hard to reach, it is possible to employ drones for close-up visual inspections. Also, they can be coupled with augmented reality systems to provide synergy and enhance capabilities of both technologies. As an example of mixed usage, of augmented reality and drones, drones with laser scanners or cameras may scan accessible parts of a structure. Then they send data to database that collects and analyzes the data to form a 3D visual imagery. So it accelerates creation of digital models in real time. Thus, well-informed decisions can be made. Drones also enable these processes to be performed with less time and cost by allowing simultaneous work plans and manufacturing follow-up. In addition to indirect cost savings from time and personnel savings, drones reduce energy consumption and related greenhouse gas emissions. The required energy per kilometer of distance traveled is so much low compared to vehicles used for inspection. For the work safety, construction sites continue to be dangerous places to conduct work. In fact, construction industries appears to be towards the top of statistics in terms of fatal work injuries. This is independent of the level of the development of a country. So managers can identify potential hazards early and act before a problem materializes with this technology. So we have an exemplar software Saha Gözü. During the software investigations, Saha Gözü software was selected. An example application was devised to test the capabilities of the software and to test the ease of use. Saha Gözü is an application that is developed by Dr. Onur Pekcan at the Middle East Technical University to make supervision on construction sites easier and increase communication between stakeholders with the compilation and processing of photographs obtained from UAVs. It may be used to measure and manage construction sites using visual tools. A digital model of the project can be created, and the field development can be followed with 3D models created remotely. Measurements, inspections, and follow-up can be provided to project stakeholders from a common platform. Also, data can be exported into other programs for building information modeling and CAD applications also. Here, as you can see, our pictures from our case study with Saha Gözü. Height measurements of structural elements perpendicular to the ground, length measurements, area and volume calculations can be made from this software. As a case study and to assess the ease of use of the program, area and volume measurements for cut and fill were conducted for a demonstration project. Steps used during calculation are presented in here. Obtaining results from the software was easy, did not require prior training actually, and took a few minutes to complete. The volume calculation tool on the menu was to calculate cut and fill volumes of excavation works in the fields. Then the perimeter of the bulk for volume calculation was selected in points as presented in figure 2. When the area selection was completed, the point cloud remaining inside the selected area was automatically selected and colored with the Saha Gözü volume calculation tool in figure 3. The software offers users a choice of 4 predefined reference planes, maximum elevation, minimum elevation, average elevation, and a fitted level. Or the user can enter a desired elevation value too. The reference plane for adjusting the point cloud level to be included in the volume calculation was selected as average level in figure 4. Cut and fill information in cubic meters and the dimensions of the selected area in square meters were given as a list by software as an output. So in conclusion, augmented reality may bring significant benefits to construction project administrations and management in several areas. Likewise, drones at the construction site have potential benefits in a number of areas, including work safety, time and cost control and savings, project progress tracking, team coordination, and also carbon emission reductions. As an example application carried out as a part of the study to demonstrate that once digitized through technologies, softwares such as Saha Gözü make visualization, planning, as well as calculations easy, quick, and within reach of existing technical personnel without rigorous training. So if there's any questions, please feel free to ask. Thank you for listening.